Good day, senior high school students, and welcome back. I am your online math teacher, Ma'am Corinne. I am so glad that you are here to join us in discussing the lesson in statistics and probability. Our lesson today is all about probability distributions. For the objectives, number one, constructs the probability mass function of a discrete random variable and its corresponding histogram. And number two, computes probabilities corresponding to a given random variable. In this lesson, we're going to define probability histogram. It shows the relative probabilities of the sample points in the form of a bar graph. Example, we have here the probability distribution in getting the number of rocks in playing rock, paper, and scissors. That is given in the table. We have the number of rocks, 0, 1, 2 as the values of x and its corresponding probabilities. We have the symbol here, P of x. If x is equal to 0, that probability is 4 over 9. If x is equal to 1, its probability is 4 over 9. And if we have 2 rocks, the probability is 1 over 9. Given this distribution, we're going to construct a probability histogram. In here, we have noted the probability distribution given in the table. And then, if you're going to graph or construct a probability histogram, you need to draw the x-axis as the horizontal line. In here, you have to write here the number of rocks or the values of x, and then the y-axis or the vertical axis for the probability in getting the number of rocks or the symbol for the symbol P of x. For the number of rocks in the table, we have 0, 1, 2. So here in the x-axis, we have 0. This one is 0, 1, 2, 3. For the P of x or for the vertical axis, we have here 1 over 9, 2 over 9, 3 over 9, and then 4 over 9. Now, let's start drawing a bar. Let's start from x equals 0, and its probability is 4 over 9. The probability pertains to the height of the variable x. So, if we have 0, you're going to start from here, from the y-axis or the vertical line up to the midpoint of 0 and 1. The height of that, of the bar, is 4 over 9. Next, if x is equal to 1, its probability is 4 over 9. The height of that is 4 over 9. And then you're going to start from the midpoint of 0 and 1 up to the midpoint of 1 and 2. That's on how you draw a histogram. And then if x is equal to 2, its height or the probability of that is 1 over 9. So you will be starting from the midpoint of 1 and 2 up to the midpoint of 2 and 3. So now, this is the probability histogram in getting the number of rocks in playing rock, paper, and scissors. Let's have another example. The probability distribution in getting the number of tails in tossing 3 coins. We have here the table. If x is equal to 0, its probability is 1 over 8. If x is equal to 1, or 1 tail only, its probability is 3 over 8. If we have 2 tails, its probability is 3 over 8. And if we have 3 tails, its probability is 1 over 8. So given this distribution, we are going to construct a probability histogram. We have noted the table in the previous slide. So we have here the x-axis for the number of tails, x values, and then for the probability in getting the number of tails, we have the symbol P of x in the y-axis. For the number of tails x, we have 0, 0 here, 1, 2, 3, 4. For the P of X, or in the y-axis, we have 1 over 8, 2 over 8, 3 over 8, and then 4 over 8. By observing the table, or by getting the values of X and P of X, we're going to draw the histogram of example number 2. So 0, the height of that is 1 over 8. That's from the vertical axis up to the midpoint of 0 and 1. Given X equals 1, the P of X is 3 over 8. The height of that is 3 over 8 from the midpoint of 0 and 1 up to the midpoint of 1 and 2. This is the bar. Next, for X equals 2, that is, the probability of that is 3 over 8 from the midpoint of 1 and 2 up to the midpoint of 2 and 3. The height is 3 over 8. And then last, if X is equal to 3, its probability is 1 over 8. You'll start from the midpoint of 2 and 3 up to the midpoint of 3 and 4. The height of this bar is 1 over 8. Now, this is the probability histogram in getting the number of tails in tossing 3 coins. Example number 3. A certain company recently opened some job opportunities. The probability of hiring X additional employees among the applicants is as shown. In the table, we have the random variable as the number of additional employees, or the X. We have 1, 2, 3, 4, 5, and its corresponding probabilities are 0.05, 0.20, 0.25, 0.20, and last we have 0.30. Given this distribution, we're going to construct a probability histogram. In here, do not forget to draw the x-axis or the horizontal axis. That is for the number of additional employees, or for the random variable X, and for the y-axis or the vertical axis, this is for the probability in hiring additional employees, denoted by P of X. We have this table from our previous slide. We have to take note of that. And the number of employees are 1, 2, 3, 4, 5. And for the P of X, we have 0.05, 0.10, 0.15, 0.20, 0.25, and 0.30. That is by 5. I mean, the distance of that is 0.05. And then if we're going to draw the histogram of this example, let's start from X, which is 1, and the probability is 0.05. So you'll start from the midpoint of 0, 1, since our starting point of X is 1, walang 0. So 1 tayo nagsimula. So from the midpoint of 0 and 1 up to the midpoint of 1 and 2. And then the height is 0.05. Next, we have X is equal to 2. Its probability is 0.20. Therefore, the height of that is 0.20 in the y-axis. You'll start from the midpoint of 1 and 2 up to the midpoint of 2 and 3. Next, if X is equal to 3, then the height is 0.25 as the probability. You'll start from the midpoint of 2 and 3 up to the midpoint of 3 and 4. Next, if X is equal to 4, you'll start from the midpoint of 3 and 4 up to the midpoint of 4 and 5. The height of that is 0.20. And then last, if X is equal to 5, the probability is 0.30. So the height of this bar is 0.30. You'll start from the midpoint of 4 and 5 up to the midpoint of 5 and 6. So this is the probability histogram in hiring additional employees among the applicants. Now, do not forget that the probability of a discrete random variable should be always equal to 1. In this example, in the probability in hiring additional employees among the applicants, the summation of P of X is equal to 1. Let's check. 0.05 plus 0.20 plus 0.25 plus 0.20 plus 0.30, that is equal to 1. Let's proceed now in computing the probabilities corresponding to a random variable. Let's have example number 4. A certain company recently opened some job opportunities. The probability of hiring X additional employees among the applicants is as shown. We have the table, the number of additional employees, 1, 2, 3, 4, 5, and its corresponding probabilities. We have 0.05, 0.20, 0.25, 0.20, and 0.30. The questions, number 1. What is the probability of hiring 3 or more additional employees? Number 2. What is the probability of X less than or equal to 2? 2, or the values of X here are the number of additional employees. Number 3. What is the probability from 3 or between 3 and 6? Let's start with question number 1, given this probability distribution. What is the probability of hiring 3 or more additional employees? So when we say 3 or more additional employees, it pertains to 3 and above. So from here, yung pinakamataas sa distribution ay 5 lang naman. So we're going to get the probability from 3 to 5. The symbol for that is P of, we have the parenthesis, starting from 3, of course, the symbol is less than or equal to X, less than or equal to 5. When we say equal, meaning 3 and 5 are included in getting the probability. So this symbol is equal to P of 3, or the probability of 3, plus P of 4, plus P of 5. We're going to get the probability of 3, 0.25, added to the probability of 4, added to the probability of 5. Final answer, we have 0.75. Therefore, the probability of hiring 3 or more additional employees is 0.75. Or in percent, that is 75%. Question number 2. What is the probability of X less than or equal to 2? So 2 is included here in getting the probability. When we say less than, yung mas mababa sa 2. Ano pa yun? We have this symbol that is equal to the probability of 1 plus the probability of 2. 2 is included here since we have the equal sign. The probability of 1 is 0.05 plus the probability of 2, we have 0.20. Get the sum, that is 0.25. So the probability of X less than or equal to 2 is 0.25. And number 3, what is P of 3 less than X less than 6, or between 3 and 6? We don't have equal sign here, so meaning 3 and 6 are not included. So only the numbers between them. That is 4 and 5. So we're going to get the probability of 4 and the probability of 5, and then we're going to get the sum. Final answer, we have 0.50. So the probability of 3 less than X less than 6, or between 3 and 6, is 0.50 or 50%. Now, it's your turn. The senior high school mathematics teachers of Camarines Sur National High School recorded the number of times the students attended online class in a month. It is recorded in the following probability distribution. Let X be the number of times the students attended math online class in a month, and P of X as its probability. We have the distribution, X. We have the number of times the students attended math online class in a month. We have 0, 1, 2, 3, 4. Its corresponding probabilities, we have 0.35, 0.20, 0.35, 0.05, and then 0.05. The question, or you have to, or what you're going to do is to construct a probability histogram. Number 2, what is the probability that a student attended math online class twice or thrice a month? Number 3, what is the probability of X less than 3? And number 4, what is the probability of 1 less than or equal to x less than 5? This is now the probability histogram in recording the number of times the students attended math online class in a month. We have the x-axis for the number of times the students attended math online class in a month as the value of x, and then the p of x, the probability. We have 0.10, 0.20, 0.30, and 0.40. Do not forget that you have to start from the midpoint of a number, then to the next random variable. And number 2, what is the probability that a student attended math online class twice or thrice a month? It pertains to 2 and 3. The probability of attending math online class 2 times or 3 times a month. So just get the probability of 2 and probability of 3. We have 0.35 plus 0.05. That is 0.40. Therefore, the probability that a student attended math online class twice or thrice a month is 0.40. Number 3. What is the probability of x less than 3? We have, when we say less than 3, 3 is not included since we don't have equal sign here. We'll start from 0, 1, and 2. And then the summation, we have 0.90. And number 4, what is the probability of 1 less than or equal to x less than 5? Yung katabi ng 1 ay may equal sign. Ibig sabihin yung 1 ay included in getting the probability at yung 5 naman walang katabing equal sign. So here, hanggang 4 lang tayo. Hindi nakasama si 5. So 1, 2, 3, 4, their probabilities. And then the summation is 0.65.